We are here at Willard School, and we're doing a lesson called The Math Things Mingle. I'd like to hear from the planning team about some of the thinking that went into how you organized this lesson.
This is our first lesson this year, so we've spent 4 months meeting pretty regularly to flesh this out and kind of lay the ideas out that we think are important and that we want to talk about. And this year the discussion has sort of focused on big ideas that connect, that thread through the grade levels and that connect a lot of the mathematics that we teach. And so the big ideas that we came up with were equality, variable, and sort of number patterns, how operations on numbers work. And so trying to figure out where in our teaching, where in our lessons, where in the textbook do kids begin to develop broad understandings of these things that connect the skills that are taught and the procedures. They spend a lot of time getting exposed to an equation that they have to solve, and they get exposed to single-step equations, and then multi-step equations, and then inequalities, and so most of our lessons are kind of, here's the thing you're going to see, and here's what we want you to do with it. Show us that you can do it. Okay, now here's the thing that you're going to see, and here's what we want you to do with it. And so what I think we've come to sort of a question about is, does that lead kids to have a connected idea of how all these things relate to each other? And is there evidence, if we throw them a different sort of lesson, will we see evidence that they're starting to make connections between things, that they've developed language to talk about them, how things are similar and different, and not just only able to perform when you say do this?
What are some of the major problems that kids have for success in algebra? And where in 6th and 7th and in 8th grade can we hit on those things that seem to be stumbling blocks? And we listed, kids have trouble with variable. I mean, having a facile and a ease with variability, variable, and with not really respecting the equal sign, not really understanding what equivalence really is about, equality is about. And then operations, and I think you said number patterns. I think we talked about sort of different representations, different ways to represent numbers as well.
For kids to succeed in algebra, what do they really have to understand? And that we've had a lot of discussions around that. So we haven't just sort of planned this lesson, but we've gotten derailed in terms of what are the big ideas that kids have to understand to be able to succeed in algebra is related to these topics of variables specifically, but equality and operations and types of numbers. And how do we avoid, like Jake mentioned, the textbook sort of takes you lockstep through, we're going to do this type of problem and this type of problem. And we tend to start to teach like that if we're not careful. And how do we bring our teaching back to the big ideas around these topics without just teaching problem types? Because if you only know how to do types of problems, then when confronted with a problem that involves many of these concepts at once, you don't have any steps anymore of how to solve it or how to even start.
One other thing, too, is I think we also thought about the successful students in algebra and what it is that they have. And I think Allison brought up one time that they have certain intuitions. That they see an inequality problem, and it may not that they have these exact sort of algorithmic understanding of the steps involved to solve it, but they, inequality, there's going to be a lot of things that will make that true. I have this thing, there's no equal sign, it's an expression, so I'm not really trying to solve that. So kids have intuitions about these number strings, the successful ones, that some of our other kids don't have those intuitions.
Something about this lesson that's different than lessons that students are used to, which is it's not about teaching them how to do something. It's trying to give them an opportunity. It's presenting an opportunity for them to kind of think about and discuss these math things, which we had a hard time coming up with. We call them symbol strings, but them as things are kind of where, that's why the title is what it is. That we're giving them an opportunity to talk about them, and we're going to see, and it's really to expose their use of vocabulary or that they don't use the right vocabulary, to expose their ability to see connections or or that they don't see connections. So it's more diagnostic. It's more a sort of formative assessment than a lesson designed to teach.
In listening to some of your planning discussion, there was real sort of indecision about whether to go with a narrow list of things for them to sort through or a wider list. Can you talk a little bit about your thinking behind the choices you made?
We thought about doing less different kinds of examples of things, but then got worried that we would just get into like, okay, these are all formulas. Whenever you see formulas, you should think about this. Whenever you see equalities, you should think about that. And so decided if the purpose is really to more see what they do and don't understand, what their instincts are or are not at this point in time, that we sort of decided to broaden it to more examples of things because it gives us, hopefully, a richer sense of what they do and don't understand.
A more simplified listing had to do, I think, with just how much disequilibrium or how much chaos they could handle as seventh graders, and in order to make the lesson work, not to throw too much at them. But we opted, I think, to err on the side of more than less.
You know, you really thought about each expression or equation that you put up there very thoughtfully, with the hope that it might bring up possibilities of some really interesting mathematical discussion. So I think there was a question about like understanding the difference between, say, a less than expression or a less than or equal to expression. So as you were picking those, what were some of the interesting side things that you were hoping kids might end up discussing?
Part of this is asking them, what do you see? And then helping them. At first, that's a strange question, and they're like, well, I'm not sure. I see lots of letters and numbers. These are like, because they're just letters, and these have numbers and letters. These are pluses. It's helping them distinguish between differences that are maybe, apparent but not mathematically significant or rich. And deciding what does that mean, mathematical richness or importance. And so, with all the inequalities, kids may notice that, may distinguish greater than or equal to, greater than, less than or equal to, less than, 4 categories. Other kids may distinguish greater than or equal to and less than or equal to, sort of, or equal to type of inequalities, and then the strictly greater than and strictly less than. And to get them to kind of say, so why is that important? Like, why do you think that's something that we want 7th graders to ponder over? Like, why is it important that we categorize them this way versus this way?
Right, and I think the prompts that Jake is going to be able to come up with to
Thanks, Jesse.
out of his magic bag of tricks. I mean, in order to suss that out, or in order to get the kids to see that, yeah, some there's a lot of ways to distinguish these, and some of those are trivial distinctions, and some are going to be more important, mathematically important.
One of the things that's sort of interesting in the design of this lesson is the use of the cards. So can anybody talk about the purpose of the cards?
Well, a part of it just enables them to move around and meet up with people. So there's that. It's used in a number of different ways, because we're given an individual card, and they have to find someone. Is that what with that?
Uh-huh.
Yeah. So that's part of the sort of just getting them up out of their seats and moving around and talking with people that are not necessarily in their group, and then they go into different groupings.
I think also, it allows us to present them. If you look over on the board, it allows us to present them with 20 math things and say, so what can we notice? And it doesn't rely on them having to transcribe them onto their page, solve something. It doesn't require them to sort of produce the math in order to talk about the math. The risks in the type of lesson where kids create it is that you never get to the big ideas because they're stumbling over integer operations or graphing or doing things. So it just allows them to have the math in front of them, to move it around, to it's very easy to move and reconfigure as their ideas change.
What kind of evidence would you like us to collect during the lesson?
Our research questions are, what evidence is there that students are able to see these symbol strings as more than just collections of letters, numbers, and operations? And what evidence is there that students are developing an understanding of the attributes and features of the symbol strings, which will be utilized in 8th grade algebra? The bell's going to ring, but I think for the observers, look for the evolution of their thinking. How does their thinking about these symbol strings evolve?